distribution system in urban area by Madhusudan Sir, water design engineer at Wadia Techno Engineering Services Limited, Mumbai. This way, the total 4 sessions highlights aspects of present industrial and field domains, whereas 2 sessions covers research domain. So overall, this FDP covers industrial as well as research domain. So my sincere request to all more than 300 participants who register for this FDP, please actively participate and interact and get more gain from this particular FDP. Thank you all. Over to
Thank you, sir.
Kalyani madam.
Thank you, sir. I now request Dr. U.R. Avari, Head of the Department Civil Engineering, AISSMS College of Engineering, Pune, to give a brief about Civil Engineering Department. Over to you, sir. Hello, Avari, sir.
Avari sir.
Vedant, can you just check if sir has by mistake logged?
No, ma'am. Sir is in the
Yes,
meeting and he's unmute. Yeah.
Hello, Avari, sir. Hello.
Avari sir, please address the audience. हाँ बोला ना सर बोला.
हॅलो
हा सर तुम्ही ऑडिबल आहात आता. सर
ऑडिबल.
yes sir.
Yes, yes.
Okay. Good morning to all. On the behalf of Department of Civil Engineering, AISSMS College of Engineering, I, Uttam Avari, Head of the Department, welcome all the dignitaries, resource person and participant for today's FDP on the recent trend in water resources and environmental engineering. I am happy to introduce the department. AISSMS College of Engineering started in 1992. Department start in the academic year 2002 with an intake of 60. Later on in the year 2012, the intake increased from 60 to 120 for the UG, and also the department start the PG program in structural engineering with the intake of 80. Our college was accredited with A+ grade by the NAC and awarded as a best professional college in city area by Savitribai Phule Pune University in the academic year 1920. The available faculty fulfill the requirement as per the AICTE norms in quantity as well as qualification. At present, 5 faculty is with the PhD qualification. 3 are submitted their thesis and shortly they may be awarded as a PhD. Other 3 is at the stage of submission of the PhD thesis, and whatever the remaining faculty are registered for the PhD programs. So within the span of 3 years, almost all the faculty in the department may be PhD qualified. All the teachers are involved in the academic as well as the recent research activity. As per the record, in the academic year 1920, Our publication is 33 journal papers, 20 conference papers, books. Department has well-developed lab as per the norms. Students are concentrated on the academic as well as the extracurricular and co-curricular activities such as sport, cultural, NSS, research and innovation, etc. During the pandemic situation, department take the advantage of lockdown and organize the activity for the benefit of the faculty and the students. Our department organized 1 week STP, 1 week FDP, and more than 10 webinars on the forefront of the civil engineering. And to strong the gap between the alumni and the present students, we organized the more than 10 sessions for the alumni interaction during the lockdown. At the head, I appreciate the effort taken by our students and staff to organize the activity during the pandemic situation. Now, our students take a lot of effort for organize the FDP. So I hope that at the end of the second day, the FDP will be successful. Thank you. And over to Kalyani.
Thank you, sir. I now request our principal, sir, Dr. D.S. Bormane, to guide us into this 2 days national level FDP with his inspiring words. Over to you, sir.
Thank you, madam. Good morning, everybody. I personally, on behalf of ASSMS College of Engineering, welcome today's chief guest, Mr. S.B. Gulbar, sir. Also welcome Mr. Patel, sir, Sudhuma, sir, Dr. Patki, my colleague, Dr. S.B. Thakre. I appreciate and congratulate Dr. Avari, Dr. Nangre, Dr. Wadkar for organizing this wonderful 2 day national level faculty development program on recent trends in water resources and environmental engineering. It's a really need of hour to organize this type of activities. Just for the information of the guests and those who are connecting first time to our institute, yes, I will introduce about my organization. This ASSMS College of Engineering started in 1992 under the umbrella of ASSMS Society. This ASSMS Society is established way back in 1917 by His Highness Excellence Srimad Sri Shahu Chhatrapati Maharaj of Kolhapur. With the vision of service to society through quality education, they have taken initiative and started this educational institutions. And just I mentioned, it started way back in 1992, and we are running undergraduate programs in various disciplines like chemical, civil, computer, electrical, electronics, telecommunication, mechanical, and we have two special programs. That is mechanical engineering sandwich and production engineering sandwich. It's a specialty of these two programs is the students are getting opportunity to work entire 1 year in the industry. That is the beauty of these two sandwich programs, where they are getting the industrial exposure for entire 1 year. And nowadays, AICT and all authorities are insisting on to have more practical approach and more skill-based education. And of course, if you see the new education policy where there is a more stress is given on the this type of programs, especially interdisciplinary concept and skill development or skill based education. Definitely, this type of programs helps to have more and more input to the students. And just coming to the SSMSU achievements, Dr. Awar has already mentioned. Our college got Best Professional College Award by South Philippine University in last year, and we are accredited. I mean, college is accredited by A plus grade by NAC last year, which at that time it was the first college to receive this grade as per the new formats. Of course, there are so many other achievements. It is because of the strong support of our honorables Honorary Secretary Sri Marujraj Chhatrapati and entire management and contribution of the faculty and staff members, and of course support and guidance from the people like you, the resource persons which are coming and guiding to our students and faculty through different platforms. So today's national level faculty development is a good initiative, and it's really important topic, and there are so many research persons who are invited because water is the basis of life and the engine for social and economic growth. Of course, water resource engineering research attempts to address challenges like how the water of sufficient quantity and quality can be made available to meet various competing sectoral demands, or how development exploitation of the resources can be carried out in sustainable manner so that its benefit extends to future generations. Like what adaptations and mitigating measures can be put in place to minimize the impact of global climate change. So, and I really appreciate your chosen different topics in 2 days, and definitely it will be beneficial for the participants because you are trying to focus on the various aspects like water distribution, that water solid waste management, and again water resource engineering, and all aspects are taken care, and I feel all the participants just do not attend for sake of getting certificate, but better to get more and more inputs and some new concept from our experts which are delivering in various sessions. So once again, I congratulate the entire civil engineering department for organizing this particular activity, and once again, I welcome all the guests and resource person for this today's activity. Thank you. Over to Kalyani.
Thank you, sir. Thank you for inspiring and encouraging our team. We also have with us Dr. S.B. Thakre, sir, Principal, Anantrao Pawar College of Engineering and Research, Pune, and member, Board of Studies, Civil Engineering, Savitribai Phule, Pune University. I request sir to share his thoughts on this 2 days national level FDP. Over to you, sir.
Thank you, madam. I think I am audible to all.
Yes, sir, you're audible.
Good morning to all the dignitaries of this today faculty development workshop, all the participants of this workshop. At the outset, I appreciate the top management of AISMS Engineering College. Also, give thanks to our mentor, Dr. Bormane sir, who is principal of the institute, for organizing such a fruitful faculty development program, which is needed in these days. We have the knowledge, the technology, and the economic resources to manage our water resources much more efficiently and effectively. But the scientific research through systematic study of the structure, behavior of the physical and natural world is continuously adding to our knowledge and tools. I know that the resource persons which is going to highlight the different topics in these 2 days are much more effective because they are in current practice. Engineer Hemanji Dhumar, who is a superintendent engineer working in the Pune region, I personally know him, how he has managed the water resources of our whole division. And also he has lot many experience what are the mishappenings if we don't manage our water resources properly. We had technology, we had all the structures, but then also if we cannot predict early situations that what will happen if the much more rainfall is there, as if we are facing the problem in this particular monsoon of 2020. So what should be done practically and what should be there in the theoretical aspects of water resources engineering, so that the budding engineers which are going to graduate from our civil engineering aspects can focus more and will minimize this type of threats by the environment. My dear friends, I appreciate the efforts of head of the department, Dr. Avari sir, their entire colleague, the coordinator, Dr. Wadkar sir, Nangre sir, other resource person, Dr. Madi sir, engineer Tambeji from Pune Municipal Corporation, today's guest of honor, Subhashji Bhujbal, Patki sir. So all together, in the water resources engineering and environmental engineering, in these 2 days, you will learn a lot of things which are really a problems which we have to face on this lonely planet. For the survival of the human being on this lonely planet, the sustainable development is very important word in today's era. So these resource persons, I hope they will have a good discussion, brainstorming sessions, and through the knowledge gain, all the participants will share with the society, with the students at large. Once again, on behalf of Board of Studies Civil Engineering, Savitribai Phule Pune University, I appreciate and give well wishes to all the participants, attendees, and also provide thanks to Dr. Bormane sir, principal of the institute, Dr. Avari sir, who is my best friend, for giving the opportunity to all the participant and the resource person by providing such a nice dais as national level. Thanks to one and all. Over to you, madam.
Thank you, sir, for your inspiring words. I now request Chief Guest for inaugural session, Shri Subhash Bhujbal, sir, to address the attendees. But before that, a brief introduction about him. Presently, Shri Subhash Bhujbal, sir, is working as a superintending engineer in Maharashtra Jeevan Pradhikaran, also holding the additional charge of Chief Engineer MJP, Pune and Konkan region. He joined MJP as an Assistant Executive Engineer Group A, selected through MPSC Engineering Services. He has done his post-graduation from IIT Powai, Mumbai, and has worked in Tata Consulting Engineers and Mazgaon Docks Limited, Mumbai. He has served as Assistant Garrison Engineer Group A in Military Engineering Services, selected through UPSC Engineering Services, India. He has experience of planning, designing, and execution of various civil engineering projects, especially water supply and sewerage systems. He has carried out appraisal of water supply, underground sewerage, stormwater drainage, and solid waste management projects under various programs like UID SSMT, MSNA, NRCP, and NRWDWP. He has experience of operation and maintenance of large water supply system. He has also served at CPHEEO New Delhi for short period for appraisal of JNN URM and UID SSMT projects. He has been part of many government committees as a chairman and member of various committees. He has visited Singapore, Sri Lanka, Israel, Spain, Netherlands as a part of government delegation. He has contributed time to time in framing of technical and policy guidelines for water supply and sanitation department, Government of Maharashtra. And he is currently chairman of Indian Waterworks Association for Pune Center. With this brief introduction, I now request Shri Bhujbal sir to address our attendees. Over to you, sir.
Thank you. Good morning and very welcome to all in Faculty Development Program jointly organized by Indian Waterworks Association Pune Center and All India Sri Shivaji Memorial Societies College of Engineering Pune. First of all, I would like to speak few words about IWWA. Actually, most of the participants are aware about the Indian Waterworks Association and its activities. Indian Waterworks Association is a volunteer body of professionals working in water sector. There are about 35 centers of IWWA across the India and more than 11,000 members. IWWA Pune Center represents two revenue divisions of Maharashtra, namely Western Maharashtra and Nashik region. And I've got membership of more than 800 members. Actually, who are the members of IWWA? If we see, they are government engineers, IS officers, engineer-in-chiefs of departments, field engineers, consultants, academicians, manufacturers of various products, suppliers, contractors, and also students. Students of many colleges across the India are also members of IWW, and there are student chapters also. So here, this college can also consider of opening a student chapter in the college. IWWA provides very good platform for all the stakeholders to exchange ideas. Apart from conducting various seminars, conferences, IWW also publish quarterly journals, which is very popular. We in IWW also conduct field visits, and there are books published by IWW on various subjects of the sector. So here I would like to take opportunity to appeal the participants who are not yet member of Indian Water Association to please come forward and be a member of this very vibrant organization. Now, during the course of this 2 days faculty development program, speakers from diverse fields are going to speak on latest trends in water resource and environmental engineering. I would like to point out that in last few years, first time water resource engineering and environmental engineering are being discussed on the same platform. I have been a part of many seminars and events, but rarely I see water resource engineering and environmental engineering on the same platform. There are many programs where both the uh, topics are discussed in different platforms, but this is the first time happening. So I would like to congratulate to organizers for this. So now every time or era has got its trends. Today we will be seeing the trends of today. But how trends comes? Basically, it's a need which drives trends. For example, since last few years, trend of 24/7 continuous water supply is going on. 24 by water supply is not new in Maharashtra. There were some waterworks in Maharashtra which were supplying 24/7 water supply. However, this trend became prominent after MJP's efforts in Badlapur, Amravati, and Malkapur. Malkapur is a classic example of 24/7 continuous water supply. With 24/7 continuous water supply came new trends in the form of planning, designing, and execution of drinking water supply system. It is in the form of using powerful design tools such as water gems and use of GIS for mapping pipelines and properties. Now it is very widely used. Means water gems, we can say that it revolutionized the design of water supply systems. Again, use of AMR water meter. It started with this 24/7 and which is now very widely used. planning of 24/7 water supply system also highlighted the importance of consumer awareness for acceptance of water meters and as well as telescopic tariff. It also started the trend of use of HDP pipes in distribution network and MDP pipes in house connections. Another development in better management of distribution network is use of automatic pressure control valves on pipelines and flow control valves in house connection. It's helping in managing equitable pressure and water distribution in the distribution network. Another recent trend in pipeline is the entry of OPVC pipes, means oriented PVC pipes. We in MGP have started using these pipes. The pipes looks very promising. We are assessing the performance of, and if the performance quoted by the manufacturers is to be believed, these pipes will prove game changer. Since last few years, double wall corrugated HDP pipes are being used extensively in underground sewerage projects. Because of its lightweight, convenience in handling, better smoothness, better jointing, these pipes has set a trend and it is being widely used. Another thing I see is coming in UGD network is the use of prefabricated HDP manholes. Now, when we look at the sewerage projects, manhole constitute about 15% cost of these projects, and which is quite expensive. Sewerage projects are far expensive than the water supply projects. In current practice, brick manholes are being used, but construction of good quality manholes require very strict supervision. Still, there remains a problem of infiltration through these manholes. So I believe prefabricated manholes are expected to solve this issue. And with these manholes, execution will be faster. If you see at the wastewater treatments, sequential batch reactor based STPs have established itself in water treatment, waste treatment plants. Another technology, MMBR, is also very popular due to its lesser footprints and cost. There are other technologies in the market being used, but they will have to walk certain distance to come with at par with the SBR and MMBR. With increasing demand of decentralized wastewater treatment and easy and cheaper operation and maintenance, use of soil biotechnology of IIT Bombay and phytorite technology of NIRI is increasing. In MJP, both these technologies are being used. We are executing around 20 projects in Maharashtra with both the technologies. And all these STPs are used in a village. These are, we can say, about 5,000 to villages with 5,000 to 10,000 population. And actually, we are looking forward to the technologies to solve our problems about O&M, because many STPs are not run properly because of the expensive operation and maintenance costs. And it also requires skilled manpower. So with requirement of decentralized STPs, such new technologies are also coming and it will going to set a trend. We have seen there are trends in design, materials, treatment processes. There are also trends in planning. So with government policies, many times such trends comes. For example, as far as underground drainage or sewerage projects is concerned, in Amrut, Urban Development Department of Government of Maharashtra, like come with a policy of execution of this project in phases. The project is designed and planned and designed for whole city. However, it is approved and executed in phases. In first part, part of the sewerage network and STP is executed, and after assessing the progress of first stage, funding for the second stage is provided. And Government of Maharashtra has taken this conscious decision based on its past expression in delay in execution of such UGD projects. Recently, Government of Maharashtra, Government of India launched Jal Jeevan Mission. This is an ambitious program to provide Har Ghar Nal Se Jal by the end of year 2024. Now, considering the work to be done under this program, it's a Herculean task. It is also going to set certain trends in the sector. The one which I immediately see about the tendering process. Now, to do such a big task in a comparatively very smaller period, government is coming with a new trend, we can say, of empanelment of contractors. With this empanelment, government is going to empanel a big contractor like L&T. So such 10-15 contractors will be executing the work of all the Maharashtra, ZP as well as MJP and GSD also. Other states already floated the tenders on such lines. So we will be seeing very big contractors working in rural as well as rural water supply, because normally these contractors work on urban project, large project, but now we expect the L&T to work on a project as small as costing 10 lakh and as well as big as costing 100 crores or something. So total work they will be like 2,000 crore, 5,000 crore they will be executing. As far as water resource department is concerned, for me, major trend they have started is use of pipe distribution network. So this has the potential to revolutionize the irrigation distribution in Maharashtra. I believe Dhumal sir, my friend Kolle sir will be talking on this during this FDP. There are many interesting lectures have been lined for you. All the faculties are very experienced and knowledgeable. I'm sure you will be enjoying these lectures. I wish great success to this program. All the best. Thank you very much. Thanks.
Thank you, sir. Thank you, sir, for your kind words. A few instructions to all the participants before we begin our next session. You are requested to only type your questions in the chat box to avoid disturbance during the session. The link of the feedback and attendance for every session and a common feedback at the last session will be shared only on this platform during the question and answer session. Link for the day 1 for all sessions will remain same, and it is shared on your registered mail ID as well as on the group. You will receive your certificates within 1 week after you provide us with your valuable feedback and attendance, which will be provided at the end of the FDP after monitoring your attendance in all sessions. With this, I, Kalyani Kulkarni, would like to propose vote of thanks on behalf of entire organizing team of this 2-day national level FDP on recent trends in water resource engineering and environmental engineering. First of all, I would like to thank our chief guest, Shri Subhash Bhujbal, Dr. V.K. Patki, HOD, Orchid College of Engineering, Solapur, Dr. S.B. Thakre, member, BOS Civil Engineering, SPPU, and Principal, Anantrao Pawar College of Engineering and Research, Pune. I would also like to express my gratitude to our college management for their constant support in organizing such programs. I would also like to thank respected Principal Sir Dr. D.S. Bormane for his motivation, Dr. U.R. Avari, Head of the Department Civil Engineering, Dr. P.B. Nangre, Convener of FDP, Dr. D.V. Vadkar, Coordinator of FDP, entire organizing faculty team and student coordinating team, and last but not the least, all the participant attendees for being present for this session. With this, I declare the inaugural session to be over and we would meet for the first session immediately to be coordinated by Professor P.R. Modak. Thank you. Over to you, sir.
you, ma'am. We are ready for the first session, day one. For resource person for the first session will be Engineer H.T. Dumar, sir. I feel greatly honored to introduce H.T. Dumar, sir, to you all. He is presently working as Superintending Engineer, Kukdi Irrigation Circle, Kukdi, Water Resources Department, Government of Maharashtra. He is presently pursuing his PhD in hydrology from Pune University. Earlier to that, he has completed his ME in structural engineering from VJTI Mumbai and B in civil engineering from Government College of Engineering Pune. He worked in water resources department at various positions as assistant engineer, assistant executive engineer, and executive engineer. He has worked for various irrigation projects in Maharashtra. Also, to his credit, he has 23 research papers which he presented at national and international level, which were in New Delhi, Macedonia, Cambodia, Australia, Turkey, Canada, Singapore, Thailand. So I welcome Engineer H.T. Dumar, sir, and would like to invite him to address the gathering. Thank you, sir. Welcome, sir.
Yeah, good morning, everyone. Thank you very much for organizing committee to invite me for such a prestigious lecture. I thankful to Dr. Sunil Thakre, Avari sir, Bormani sir, and last but not least, Bhujbal sir. He has introduced a lot about Water Resources Department and MGP, and also he is chairman of Pune chapter of IWW. So he has given very good speech. After that, I will proceed to my presentation. Am I okay? Please allow me to share my screen.
So yes,
Yes, sir.
I've given you the permission. Yeah, you can share.
Is my screen visible?
No, sir. No, sir.
I think that option is share. Now share screen. Okay.
Yes, sir, it's visible now.
Okay, I will start my presentation now. As I am not a regular lecturer or speaker, I am requesting all of you to bear with me, but take a technical thing from my presentation. I have tried my best to incorporate all the experiences which I have experienced during last 25 years in government of Maharashtra in water resources department. Thank you, sir.
Hello, Dumar sir, your voice is not audible. Dumar sir,
Sir, excuse me.
Huh? Am I audible now?
yes sir, please start.
सिस्टम ऑडिओ शेअर्ड नाहीये तुमचा.
पण तुमचा
हा?
व्हिडिओचा आवाज येत नाही सर.
हॅलो,
Dumar sir,
आवाज
तुम्ही व्हिडिओ दाखवताय का? आवाज येत
हो
नाहीये,
मी
आवाज येत नाहीये.
बिलकुल येत नाही का?
हा
मग
आता येतोय, पण तुम्ही
व्हिडिओचा
व्हिडिओ प्ले
साऊंड येत
केलाय का?
नाही.
ओके ओके, मी व्हिडिओ लावला होता, मी आता ऑडिओ
हा
प्ले करतो.
व्हिडिओ
चला,
ऑडिओ तुम्ही पीपीटी सुरू करा.
ठीक आहे ठीक आहे. आय विल स्टार्ट फ्रॉम बिगिनिंग.
ओके.
आता स्क्रीन दिसतंय माझं?
हो येस येस, स्क्रीन शेअरला स्लाइड शोला जाऊ. येस येस.
ओके, स्लाइड दिसते का माझी?
हो स्लाइड दिसते, तुम्ही सुरू करा सर.
Okay, welcome to everyone. Myself Hemant Dumar. I am working as a superintending engineer in Water Resources Department, Government of Maharashtra. My topic is enhancing effectiveness of water resources systems. So before going to presentation, let us see what are the water resources systems. First one is sources of water resources. It may be river, lake, sea, directly rainfall, or any other natural resources. Then second comes to the storages. Storages may be dams, ESR, GSR, etc., etc. Then treatment plants. And fourth one is conveyance system. Conveyance system may be piped irrigation network or canal systems, etc. Before going to enhancement, I would like to show two pictures. One is from foreign countries or European countries rivers. This is the typical picture. It may be from Paris. See the river and river shore and banks, and water is seen very clean. And though they are not drinking water, but it is drinkable water in the cities. Another picture, this is the Venice city in Rome or Europe, sorry, Italy. The city is, doesn't have roads, but it is connect the various lanes and by canals. The boats are seen. So convenience system is boats. And see the cleanliness of water. As again, I am going to show you picture from India. India, all of us know that river is worshipped as a goddess. Apan Ganga Maya, यमुना मैया असं देवी म्हणतो. आणि हे पिक्चर आहे आपल्याकडे. हा पंढरपूरचा लास्ट वीकचा फोटो आहे. आय वॉज विजिटेड लास्ट वीक पंढरपूर गव्हर्नमेंट वर्क. See, the Sulabh Sauchal is located on the bank of river. And if you see, this drain holes or drainage directly disposed in the Chandrabhaga. And this is a situation at a holy place like Pandharpur. This is another picture. This is also from Pandharpur. See the Visarjan of Ganpati done on the banks of river after river water level is dropped. How the dirtiness and everything around the god is seen. So my opinion or my this thing is enhancement should be in our mind, not in technology. So if you have enhancement in our mind, then only we can have enhancements or advancements in water resources in technology also. Now let us see the growth in water resources department. If you see, if you assume our generation, that is 1995 to 2020, it is 858th generation. The total progress in water resources is in last 25 years equivalent to last 849 generations. It means from the civilization to 1995, what was the progress in water resources department is now in this 25 years. Sorry for interruption. So I mean to say the total progress in this sector as in other sectors is equivalent in last 25 years to last 849, that is after civilization and 20,000 years. So this is a 0 to 849 generation is equal to 858 generation. If you see the after civilization, when whale was invented, the automobile car was invented after 2000 years, around 2000 years. And after in 100 or 150 years, we can have such modern cars like auto gear and everything. So that development is within 25 years. We can see the advancement in water resources in 4 stages. One is planning, designing, and investment stage. Second one is construction stage. Third one is operation and maintenance stage. And fourth one is others. Let us go to the planning, designing, and investigation stage. So for this, in planning, designing, and investigation, one most powerful tool as available is GIS. Second is remote sensing. Third one is digital illusion models. Fourth one is drone survey, etc., etc. And fifth one, but important, is processing of all above. Now let us go to the example which is used using GIS and DM technology softwares. This is typical catchment area picture generated from DMs. This is Pune city, Pune catchment. This is Bund Garden. The catchment area is delineated from global mapper software after downloading the DMs from website, and you can see the streams and dams and various catchments shown on colorful manner. So this is the typical picture. Nowadays we can use GIS survey as a preliminary or recognition survey, as earlier we were doing from topo sheets. Now you can use these tools powerfully in water sources. This is a typical picture how GIS can be used for water resources. This is a Khadakwatla Dam, and government of Maharashtra has proposed tunnel, alternative tunnel to government of Maharashtra proposed alternative to existing canal in city for bypassing this open canal by tunnel. So if you see the existing canal alignment, it starts from Khadakwasla Dam, then goes to from Sinhagarh Road to then Parvati Paitha, then this Swargate, then this is race course. Race course, Parvati Paita, Swargate, race course, and it then exits Pune city after Hadapsar into Kursungi. So these sorts of advancement can be used the tools for planning and designing. Now we'll go to the how this GIS technology used for tunnel alignment survey. This red color is existing canal in Pune city, and this blue one is alternative tunnel. So using global or Google Earth, I have planned this thing in. I have planned these alternatives in then in Google Earth, and then I've tried this downloading the DEM from website, and then processing the DEM on Global Mapper or ArcGIS software. These alternative alignments can be seen. The same alignment can be seen on this three-dimensional view, and we can draw a L section, very good L section of such existing alignment or ground levels with these various softwares. So this is application of advanced technologies in for planning, designing stages. Now, the same work can be done through drone or DGPS survey. Now, second stage of water resources is during construction. First stage was planning, designing, and investigation. Now, during construction, we can use this technology or advancement or enhancement in automation. Then various sensors we can put. Then data logging of during construction. Then data processing of this various available materials, etc. We'll see in details in example. Then decision support system. During construction also we can have decision support systems. Typical example I will share with you that all of us know that Temgar Dam is located on upstream of Khadakwatla Dam in Mulshi Tahsil, Mulshi Taluka. The dam grouting work is in process. This is digital model of Temgar Dam. It is trapezoidal masonry dam. It is having a height of around 80 meters and bottom width around 60 to 70 meters, depending on height. So this is digital model. We have to this dam body is discretized in various elements, and we have to grout it from top, from bottom, so upstream, from downstream. So wherein dam bodies are discretized in various segments, so that we can have the assess or judge how much quantity of grout has been introduced or poured in dam body, at what time. That real-time data is also available. So this is typical one monolith or segment as shown. This is inclined grouting, this is vertical grouting. At any time or at any moment of time, we can have, this is gallery, this is gallery, this is dam body gallery, this is foundation gallery. So we have grouted the dam from top, from galleries, then from downstream, from upstream also. So the grouting quantity, we have to access the grouting quantity and assess the quality of existing work to judge the porosity or leak property of dams. So this so for assess this quantity and quality, we have installed one SCADA system in on the dam site, which was helpful to log the data digitally, assess the data, process it, and to take decision. So the decision support system has been developed. Though this system was it was automation control system. Then it was having remote monitoring at Pune office. Then field devices were installed. Cement inventory and consumption record system was there. It was used by barcode. Then connectivity of handset devices like mobile or walkie-talkie. Then online drilling and grouting and depth monitoring was there. Then auto mixing of cement, water, and other parameters or other ingredients from cement for every 1.5 meter depth of grouting. Then data analysis report was done automatically. This is typical system. Here we can see the web server, PLCC control system, field instruments, then cement inventory and consumption record system, then a remote monitoring station at Pune office, and then these are connectivity shown in various handled or field devices, handheld devices. So this was a SCADA system which was introduced in time first, and everything was monitored online. This is another typical picture of this PLCC control system, water mixer. So everything was digitized and everything was monitored. And most important thing is it was logged on a web server. Now, what we water resources department do in advancement. This is typical picture of Mysal lift irrigation scheme, which is in Sangli district. It is having 1,09,000 HP. I will repeat, 1,09,000 HP for single scheme. It means 100 megawatt when the power was 110 megawatt power was consumed. Power is consumed for a single lift irrigation, which is the largest. It was the largest in that time in Asia. So it requires very, very advanced technologies, very, very advanced equipments, the what surge analysis, etc. Then monitoring, controlling, sensing. So these are huge. The single pump house of stage 1 of Mysal is having 30,000 HP pumps, 1,000 HP each pump, and such type of pumps are 30 numbers. So 30 into 1,000, 30,000 HP at a single place. So you can judge what the advancement is there. Another policy which is adopted by government of Maharashtra and also government of India, that is now we are going to shift from conventional canal, open canal system to piped irrigation network or PIN. Government in 2018, government of Maharashtra adopted this policy. The objective of this policy is per drop more crop. All of us know that if we supply water by pipe network, of course the leakages and losses will be less, and so the efficiency will increase from now conventional canal system has efficiency of 49%. It will go to 71% by piped irrigation networks. And if you further go with that piped irrigation to micro irrigation, that means if you supply in spite of flood irrigation, we can, if you use drip or sprinkler system, we can use increase efficiency by 49 to 71% in first phase and in 91 in second phase. Now let us see the example of Gundoni project. Gundoni project is a project located in very nearby. It is behind Siangad Dam. The Gundoni Dam is located in Vella Tehsil at the portal of Rajgarh Fort, and it is having 4 TMC of water storage capacity. It has irrigation area or command area in Bor, Velle, and Purandar Tehsil. This is the first time of scheme in India where direct water is supplied to drip at drop of drip. Means we can see water either in dam or directly at the root of crop. So this is first of its sort where dam head has been utilized for creating this pressure In conventional dams and canal system, we have to dissipate the energy after outlet. We have to dissipate the energy after the outlet to flow in canal. So this sort of irrigation project, piped irrigation network project, is very special of its character. I will show a small video of this Gundoni project. Hope this audio is audible to all. आवाज ऐकायला येतोय?
सर व्हिडिओचा आवाज नाही ऐकू येत आहे.
Oh, sorry, sir.
असं त्यासाठी तुम्हाला परत स्क्रीन शेअर करावी लागेल आणि तिथे वरती एक ऑप्शन असेल एनेबल सिस्टम ऑडिओचा.
I'll because this is most important this thing.
सर वरती ऑप्शन असेल स्टॉप स्क्रीन शेअरचा. हा स्क्रीन शेअर स्टॉप करा सर. हो
नाही स्क्रीन इथे इथे रेड दिसतोय काहीतरी.
हा स्क्रीन शेअर स्टॉप करा सर. ते स्टॉप स्क्रीन शेअर करा. हा आता परत शेअर करा सर आणि शेअर करताना लेफ्ट हँड साइडला टॉपला 2 ऑप्शन असतील सर. ते एनेबल करायचे होते सर शेअर करायच्या आधी. सर एकदा स्टॉप केला ना सर.
ओके
तुम्ही ते एनेबल नाही केलं सर ऑप्शन.
नाही का?
नाही
नाही दिसते ना आता म्यूट केले.
स्क्रीन दिसतीये सर. तुमचा व्हिडिओचा साऊंड प्ले नाही होणार आहे परत.
आवाज येतोय?
नाही सर.
ओके
सर स्क्रीन शेअर स्टॉप करा आणि शेअर करताना हा आता शेअर वरती क्लिक केलं ना सर तर लेफ्ट हँड साइडला टॉपला एक ऑप्शन असेल तुम्हाला की शेअर शेअर कंटेंट म्हणून. तर तिथे मोशन अँड व्हिडिओज ते सिलेक्ट करा सर. व्हिडिओज अँड मोशन असा एक ऑप्शन असेल सर सेकंड. तो केला सर ऑप्शन सिलेक्ट.
मोशन आणि व्हिडिओ देतो टेक्स्ट आणि इमेजेस म्हणतात खाली तो.
हा टेक्स्ट अँड इमेज वरती क्लिक केलं ना सर तर तिथे ऑप्शन येईल अजून एक मोशन अँड व्हिडिओ.
तो खालचा तो ग्रे येतो तो शेअर होत नाही तो.
शेअर तो व्हायला पाहिजे. ठीक आहे सर मग परत स्क्रीन शेअर करणार. माझा नॉर्मल स्क्रीन शेअर करा. आय गेस काहीतरी इश्यू आहे टेक्निकल. मग
शंतनू
येस सर.
तो व्हिडिओ बघ साहेबांचं काय होत नाही.
सर मी बघतो त्यांच्याशी कम्युनिकेट करतो.
खाली ये रे जरा लवकर. इथे आहे ना आपण बहुतेक ते हे अलाउड केलं नाही त्याला मूड आवाज जात नव्हता. इथे मी व्हिडिओ बंद केला. या व्हिडिओ बंद केला आता. इथे आहे ना ऑप्टिमाइज फॉर मोशन आणि व्हिडिओ. काय होत नाही शेअर होत नाही माझा आवाज, व्हिडिओ जातो पण ऑडिओ जात नाही. कुठले वेबएक्स? आता व्हिडिओ बंद केला त्यामुळे यू कॅन कम. हे पण करू शकतो. शेअर करा. नाही हे पॉवर पॉईंटचं काढलं तू का नाही? मीटिंग कॅमेरा अनेक व्हिडिओ. तिची ऑडिओ प्रत्येक स्टॉप शेअर करून परत शेअर मल्टीमीडिया. त्यांनी काय सांगितलं मला, ते जे आहे ना स्टॉप शेअर करा आणि परत इथे शेअर करा. ज्यावेळेस तुम्ही शेअर करता की नाही त्यावेळेस इथे इथे ते पाहिजे, खालचं आहे का नाही ते यायला पाहिजे. ते आपलं कुठेतरी त्याला वेबएक्सला आपल्याला. तुम्ही रेकॉर्ड करताय का? नाही मी नाही करत, त्यांनी कुठेतरी करत. रेकॉर्ड ऑफ करून टाकू. रेकॉर्डिंग चालू आहे. दुसरी स्क्रीन घेऊन काय होतं, ही घेतली होती ना आपण त्याच्यात दुसरी. कसं करतात सेटिंग्स होतं इथे. ही स्क्रीन घेतो का मग ते मेन्यू बार वगैरे आलं होतं सगळं. जेव्हा ते करतो ना तसं. मग अशी मेन्यू बार उघडला होता ना सगळं इथे आहे ना. आणखी एक मिनिट होतं. ऑडिओ रेकॉर्ड नाहीच करायचं.
साहेब व्हिडिओ पाठवताय का मेलवरती? मला कुठून शेअर करतो आम्ही? मला मेलला रिव्हर्स पाठवा व्हिडिओ, आम्ही शेअर करतो.
दॅट इज गुड आयडिया.
हा
मोठ आहे ट्राय करून
तुम्ही मला हे करा,
शेवटचं ट्राय करून.
येस
आता फक्त एक
येस सर.
येतोय का आवाज?
सर स्क्रीन शेअर नाही झाली.
येतोय आवाज?
नाही येत आहे सर ऍक्च्युली.
ठीक आहे, मी हा व्हिडिओ शेअर करतो, आपण मग तो शेवटी पाहू.
चालेल सर.
किंवा मी याच्यावर घेतो ना, मी पॉज करतो आणि हा व्हिडिओ तुम्हाला मेलवरती शेअर करतो. ओके.
हो सर.
मोठा आहे पण तो, बरं का.
चालेल सर. हो.
493.
वेदांत आणि शंतनू मी तुम्हाला लगेच पाठवतो. साहेबांनी पाठवतो.
हो सर.
तर मी तांबे सरांसोबत कम्युनिकेट करतोय, प्लीज 2 मिनिटं.
हा कर, तू तांबे साहेबांशी कम्युनिकेट कर.
कुणाला पाठवू मेल? हा
सर मला करा मेल, तुम्हाला मी सकाळी मेल पाठवलाय त्याला रिव्हर्स करा मेल. PB नांगरे.
नांगरे, प्रकाश
हा
नांगरे.
हा, येस 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 येस.
तोपर्यंत आपण पुढचं प्रेझेंटेशन घेऊयात का?
हा करा कंटिन्यू सर, काही प्रॉब्लेम नाही. प्लीज कंटिन्यू युअर फर्दर सेशन, नो प्रॉब्लेम.
येस सर, थँक्यू. Sorry for interruption. Now I am again. Am I audible to you?
येस सर. येस सर.
पुढचा ऑप्शन, नेक्स्ट stage of water resources is operation and maintenance. This operation and maintenance, we require technology in siltation of dam, siltation in canal, pre and post monsoon inspection of dams, then water related sensors and data acquisitions, then automation at various stages. This is the yes. Now I am going to present an example how technology is used for canal inspection using drone. This is typical location of Kukudi project in Ahmednagar district and Karjat Taluka. This is a drone survey done by done for this Kukudi left bank canal, and this canal can be extracted by this drone survey. This is equivalent to DEM or a digital model having XYZ coordinates of each and every pixel, and we can further proceed with we can have cross sections, L sections of these canals by using drone and DEM cameras. This is a typical cross section. This disturbed cross section is shown. So with this, this is the canal, and this is picture of canal. So you can see the quantity here is siltation, here is scouring, and this quantity we can excavation and banking quantity can digitally calculated automatically. For pre and post monsoon inspection of dams through drone, I utilize this for Wada Dam. Wada Dam is located in Junnur Taluk of Pune district. This is Google image of Wada Dam, and this is Shivaneri Fort. This is picture of Wada Dam, and I have utilized this. This is height is 30 meter, length is 1875 meters. This is typical drone picture you can see. how the drone was used for detailed investigation or inspection of dams. Most of the points are not accessible during monsoon or after monsoon, and such points can be accessed. The automatic program is given to drone so that it can go to particular place, have picture or have video, and it is programmed so that it flies automatically, go to particular points and have pictures and this thing. Now with this was a drone survey. Regarding now other advancement in water resources department or water sectors, we can use this drone survey for crop survey, crop identification, flood forecasting, and then irrigation applications. Then now we'll go in details for how the drone is used for crop survey. This is a typical village image surveyed by drone. This is orthomosaic image with village map. These images are superimposed with village maps, regular village maps, so that we can identify the owner of this village plot, and we will identify the crop with its own digital signature of crop, and we can assess the crop area, and we can create automatic bills for particular owner of this land. These are using software. You can identify area of each survey number using high resolution image crops by zooming it, and these crops are identified by software itself, like RGS or other equivalent softwares. Now, for flood forecasting or water surface profile, we can use this is also part of water resources department, because flood monitoring, flood forecasting, and flood mitigation are the principal duties of water resources department. The advanced technology can be utilized for flood forecasting. This is a typical. In this map, we can see various rivers. This is Krishna coming from Dome. This is Koina coming from Koina Dam. This is Karad. This is Varana. Sorry, this is Panchaganga. This is Varana, and this is Krishna. So last year in 2019, there was severe floods in Krishna River in last year in 2019, July 20, 24 July 2019 to 14 August 2019, there were heavy floods. Am I audible or visible? So this
Yes,
Sir,
sir,
yes,
you're
sir.
audible.
Yes, sir. Please continue.
okay. These flood lines are marked with HECRAS software, and the flood analysis has been done under guidance of Dr. Sunil Thakre, who is present here. So this type of technology is a prime duty or main duty in flood period. So this is typical flood line mapping or flood inundation mapping using HECRAS or Mike 11 software, any software available. This is in plan. See here we can see the dates. On left, right top corner, these are the dates and times. Various times, real time, we can have flood mapping. This is 10th August, now 11th August 2019. So such type of advanced technology we can use for this water resources department. Then similar way, we can have this L section from Karat to Alamatti Dam. This is L section of river, Krishna River from Karad to Almaty Dam. This is typical cross section nearby at Sangli, and this is perspective view. In large screen, we have seen the flood inundation on Google Map, but in this screen, on a single screen, we can see the L section perspective and cross section, how the water levels are changed. See, you can see the cross section, the level is rising. Also in L section, level is rising. In perspective also, we can see the flood inundation spreading in floodplains. So this is L section is rising, now cross section. Now we'll proceed to how the irrigation other apps are used in Kukudi irrigation circle for irrigation rotation management. All of us know that the main function of water resources department is to supply irrigation water to farmers at various locations. This Kukudi irrigation rotation app has been developed for the Kukudi Lebdang Canal, which is the longest canal in Maharashtra. It is having command area in 3 districts of Pune, Solapur and Ahmednagar, and it is having length of 249 kilometers and 90,000 hectares. Around 250 villages are irrigated by this thing. So the objective of this mobile app was to use single platform to collect canal-wise and outlet-wise data instantly, real-time data to develop effective decision support system, visual presentation on schematic, map, view with pop-ups for focus on certain sections to generate reports which will be helpful to prepare ISR, that is irrigation status report, Jalalekha, that is a water audit, then chat facility to help personal and group communications. Any instructions can be given by this through app. Problems in existing system, why we utilize or why we generated this app, because more efforts are required to collect data. We have to call, we have to wait for SMS, or we have to wait for WhatsApp. Then manual efforts are required to calculate the usage. So if the data collected, we have to prepare it in Excel sheet and calculate too many huge calculations required. So this can be avoided by this app. Then it was manual data or data which is available through Excel or thing. It is very difficult to have decision, to take decision. So this will help us for decision making. Then live tracking of water. For any instance, we can have live status of irrigation water in physical or manual. It is not possible. The solution introduced Kukuri irrigation rotation app is one-point solution for rotation system, which works from preliminary irrigation program, that PIP, to completed irrigation program, that CIR. This is typical application dashboard as shown. This is dam dashboard, canal dashboard, outlet wide data. This is mobile view. Another, who can access this app? This app can be accessed by sectional engineer, deputy engineer, executive engineer, superintending engineer. And these are some, what are the features of this care app? That notification center is there, picture upload, then live chat is available, GPS tracking is available. You can view it on maps directly. Real-time dashboard is there. Live reports can be generated and powerful management information system is there. Annual report generation facility. We have to prepare so many annual reports for budgeting or for water auditing, like water use, area irrigated, crop wise area irrigated. So many details are required to submit the water audit to the concerned authority. So after irrigation rotation or after irrigation this thing, we have to work for too many time. We have to sit and we have to calculate so many things and generate reports. But now this generates reports are generated automatically. This is schematic view of this decision making. This is a cluster of 5 dams: Chilewadi, Pimplavadi, 6 dams: Chilewadi, Pimplavadi, Yedagaon, Manido, and Dimbe. This Dimbe, this 5 cluster of this 5 project is called Kukudi project. and this is Chilewadi, Pimpalwajoge, and Edgaon, Wadaj, and Dimbe. This is easy canal gauge reporting facility. Then dam-wise canal-wise status. This is dam content at any particular moment, particular rotation period, Edgaon, Chilewadi, and canal-wise this thing, canal-wise report is there. Then we can have for junior engineer level or senior engineer level, we can have outlays-wise details. This was my presentation. Thank you very much. I would like to whether the video is available or not.
Sir, please send the email. You're just uploading.
I have sent already. I have already sent it email. It is on way. It is sharing on Google Drive because it is very big. Okay, I will show my video on my this thing and I will narrate this. I think that is the way to have.
Yeah.
Okay.
Sir, can you show the video from my files presentation? I think.
Pardon?
Can you show the video from my files, like instead of showing it from the presentation? I
Okay,
think
okay. I'll
the
show it from
network
my
loss.
file, sir. I will directly run that video.
Yes, sir.
येतोय का?
Nice, sir. Audio is nice.
Okay, I will narrate this video.
Okay, sir.
This is first we are showing how the Pune has culture and these things. So how the Pune has a background of education and traffic, well-known education systems. Then near to Pune, how the rural area and is in demand of water. Now this is the Google image of this video. Am I audible now? माझा आवाज येतोय का आता?
हो, तुमचा आवाज येतोय सर. व्हिडिओचा नाही
ओके ओके मी बोलतो आता. हा गुंजवणी डॅम आहे. दिस इज गुंजवणी डॅम लोकेटेड इन नियर विलेज कानंद and Bopalgarh. This is dam and this is water stored in So this was created for farmers. So location of Gundavani Dam. So this is shown in command area of Gundavani Dam. So more per crop is essential here. So we have source creation, distribution, management, and field application efficiency. This is photograph of real photograph of Gundavani Dam. The Ardhan Dam with side spillway. It's at maximum height of meters. Then 104 million meter cube, that is around 3.67 TMC of water, 4 TMC. Annual utilization 4.19 TMC. Two radial gates are fell. The project is complete. Yeah, this is the first irrigation project in India
which offers 24/7 for 365 days waters. And this is irrigation network. And water can be seen only in dam or at the root of crop. This is the very unique feature of this dam or project. And minimum 20 meters pressure head is maintained at each and every point. This is command area. This command area starts from this dam, and initially it is narrow, then it goes on widening, and after 50 kilometers, it is one lift irrigation scheme, Naranpur lift irrigation scheme. This is command area in Purandar Tehsil of 5,400 hectares, and most of the area is in drought-prone area. 173 the water resource associations has been planned, and total command area is 21,392 hectares. So this is fully designed with fully hydraulic SCADA with smart networks. So many equipments are planned to be installed here. This is the command area of this Gundoni project. Main pipeline is 86 kilometers long. Total 16,000 hectares is by gravity, and it works on gravitational head of dam. No energy is required to pump this or this. Total energy used is from dam water available. Second part is lift. It is commanding 4,500 hectares. It has 58 kilometers main pipeline, and total lift is 150 meters. This total design has been done with modern softwares like WaterGem, as Bhujbal sir told. So we are using this WaterGem softwares, and whole command area is detailed surveyed, and we are going to provide water through drip only. But every farmer has to build his own drip. Where government of Maharashtra, WRD is going to give water pressure required compatible to drip at each and every outlet. This is main feature. And what is more beauty of this project is we have saved 35% of cost by after doing piped irrigation network and using this technology. We are saving 35% by open canal, because land cost is more now. Piped irrigation network is cheaper, but more another important beauty of this project is we are using water head which is available in dam. So pipe size is reduced, so the cost is reduced by 35%. This is command area. This is a real command area. This is cost reduction by 30%. This is again very important. This technology we have imported from Israel. That is the outlet management system, and whole system is automatically and SCADA system. There are 173 water resource associations. We are going to build one chowki or room over there, control room at every WA, and it will be having this desktop and control system at each and every village, and mobile alerts. Each and every farmer will get equal water with 20-meter pressure head. Every chuck we are going to provide water meters, so that we are going to supply volumetric water.
this type of as this head is ready for drip irrigation. Another design feature of this, we are going to have this distributive management system and then outlet management system. So we are again going to distribute this 24 hectare chuck into 3 hectares, and every 3 hectares chuck we are getting water for 4 hours a day, because in drip irrigation we have to provide water every day, not like flood irrigation you can supply 7 days or 10 days, but drip irrigation we require water for every day. So every day each and every farmer will get waters. Outlet management system, distribution management system, and wireless energyless communication. It will work on most of the controlling system will be. This is vandalism or alert. Means if there is mishap or behavior of any farmer or this thing, it alert will be system will be closed automatically. Farmers will get SMS alert regarding water quality and water availability and cropping pattern. Officers can access this through mobile or smartphones or laptops at offices. Data log will be available in sections. Another feature of this project, National Highway number 4 or near that village, I don't remember its name, but we are going to use a push-through technology for driving this underground. Without interrupting the road, we are going to drill holes below the highway, and this highway will go and will do this push-through technology will be used to drill holes below the highway. And we are going to install this at every village. We are going to install this control room and training centers how to use this. Water Resources Association. Every farmer will have to compulsory become a member of WA. 177 crore saving was there. Yeah, for open canal network, we require a lot of land for borrow pits, canals, excavation, etc., etc. But due to this piped irrigation network, we are going to bury the pipes underground. So the perpetual saving of command area, which is very costly land, 1200 acres. And also minimize the construction resistance, because farmers generally oppose nowadays nearby city farmers oppose this canal works. And because of piped irrigation network, we have improved the ease of construction, reduced completion period. So this was my video part of video. Sorry for inconvenience because of some audio technical problems. I couldn't have continuity in my lecture. I think it's thank you very much, and thank you very much for patiently listening to me. This was my sharing my experiences, and this whatever I have shared was is a live projects or which are in existing. Thank you organizers, thank you Nangre sir, thank you Wavari sir and Borma sir.
Thank you, sir. Vedant?
ठाकरे
Yes,
सर
sir.
आहेत का?
आहेत सर. ठाकरे सर नाही आहेत सर. ठाकरे सर आय गेस रिलीज झालंय.
Vedant, please share the feedback link and
Okay,
take a
okay.
photograph of all audience as well as all.
Yes, sir. Yes, sir. Dumar sir, can you just stop the screen sharing? We'll
File
just
is
take a
still
photograph.
attached here.
Yeah.
Okay, okay. of the screen sharing. Okay.
Thank you, Duma sir, for enlightening all the participants with your valuable thoughts, sir. Whatever advancements government is trying to implement on the that you explained properly, and that was very much possible with your vast field experience, and I hope all the participants will benefit from that. I would like to have your support and further association with the Department of Civil Engineering, AISSMS College of Engineering, sir, and welcome, sir.
I request everyone to please turn on their videos so we can take a photographs.
All of you start your video so that we'll take the photograph. It's a photograph session. After each session, all of you start the video. So it's my request to all, please start your video. We'll take a photograph after each session. Vedant, please carry forward.
Yes, sir. They're turning on the videos. I am waiting for everyone. Yes, sir. Done with the photographs. Thank you, everyone.
Nangre, sir. Hello. Are we ready going forward with the session 2? Nangre, sir. Vedant. Tambe sir has joined.
Hello, hello, good morning. Good morning. Hello. Am I audible?
Yes, sir, you
Hello?
are. Good morning.
Yeah. Hello. Can I start?
Yes, sir.
Just a minute, sir. Yes, sir. Just a minute.
Sir, I will quickly introduce you, sir, to the participants, and then
Yes.
so
Pardon?
we'll start the sir.
So, just some disturbance is there.
Tanvi, sir, actually your bandwidth is low. Yeah. So I guess,
So what can I do now?
so your connectivity. I mean,
Hello. No, here I'm having full connectivity. Yeah.
okay, sir.
Hello.
It was showing that you have low bandwidth. Yeah. Hence it was your voice was cracking a little. Yes, sir. Now it's fine, sir. Yeah.
Okay,
is okay now?
welcome to the
Hello?
Yes, sir, pretty much audible, sir. Yes, sir, we are ready to start with the day session 2 of the day 1 with resource person as engineer R.G. Tambe, sir. I'll briefly introduce Tambe sir to all the participants. is presently working as Joint City Engineer, Water Supply, Drainage and Environmental Department, PCMC, Pune. His educational qualification includes Masters in Town and Country Planning and B in Civil. He joined PCMC on 27th of June 1991. He worked for the treatment of raw water, making it fit for drinking and drainage department. He worked in various bridge projects, then slum department, water supply department. His research contribution include he has delivered more than 500 lectures on rainwater harvesting throughout Maharashtra state. Thank you, sir, for joining us, and I would invite you to address the gathering. Thank you, sir.
So, this is my talk to you, interact with you. I've been given the subject of challenges and improvement in water distribution as far urban area is concerned. Now, I think I'm the right person to discuss all these issues. As already told in introduction, I am working as Joint City Engineer in Pimpri-Chinchwad Municipal Corporation, and I am dealing with water supply, drainage, and environment. So these issues are very hot issues these days now. मी मुद्दा म्हणून मराठी बोलता आता, कारण आपल्या मातृभाषेत आपण जास्त चांगल्या प्रकारे आपण एक्सप्रेस होऊ शकतो. बेसिकली जर आपण पाहिलं तर जे चॅलेंजेस आहेत, जी आव्हानं आहेत प्रशासनासमोर पाणी पुरवठ्याबाबतची, ती फार क्रिटिकल आहेत. म्हणजे मी फक्त पिंपरी चिंचवड पुरतं मर्यादित बोलणार नाहीये, तर भारतातील नव्हे तर जगातील सर्व शहरांमध्ये हे प्रॉब्लेम्स, या अडचणी सगळ्यांना जाणवत आहेत. कारण आता प्रत्येक देशाचं शहरीकरण वाढू लागलेलं आहे. जर समजा कमी जागेत जास्त लोकसंख्या वाढायला लागली तर मग निश्चितपणे पाण्याच्या अडचणी येतातच. आता आपण जर पिंपरी चिंचवड महानगरपालिकेचं उदाहरण लक्षात घेतलं तर पिंपरी चिंचवड महानगरपालिका ही 1982 साली एस्टॅब्लिश झालेली आहे, आणि त्यानंतर ज्या वेगानं लोकसंख्या वाढायला लागली त्या वेगानं आम्ही प्रयत्न केला की पाणी पुरवठ्यातही सुधारणा करायची. आणि आता 2011 साली 2001 साली जर विचार केला तर लोकसंख्या साधारणतः 10 लाख होती, 2011 साली 17 लाख होती, आणि आता 2020 म्हणजे संपलेला आहे आणि लोकसंख्या जवळजवळ 30 लाखाच्या जवळपास पोहोचलेली आहे. आणि या पार्श्वभूमीवर जर मी विचार केला, पाण्याचा जो उद्भव आहे, सोर्स आहे, तो तर आमचा लिमिटेड आहे आणि लोकसंख्या मात्र वाढत आहे. मग हे जे लोकसंख्या वाढीचं प्रमाण आणि पाण्याची उपलब्धता यात जर कमी जास्तपणा आला तर निश्चितपणे अडचणी होतात. आणि जे काही आव्हानं आहेत, आता प्रथम आव्हानं जे काही आमचे वॉटर डिस्ट्रीब्युशनची आव्हानं सुरू करण्यापूर्वी आपण प्रथम पाहूयात की पाणी तुमच्यापर्यंत कसं पोहोचतं. तर प्रथमतः परत पिंपरी चिंचवडचं उदाहरण देतो. आमच्या इथे रावेत इथे बंधारा आहे. रावेत इथल्या बंधाऱ्यातून आम्ही जे काय रॉ वॉटर पंप करतो आणि अप्पू घरच्या जवळ जलशुद्धीकरण केंद्र आहे, त्या तिथे पाण्याचं शुद्धीकरण होतं. शुद्धीकरण म्हणजे काय की त्याच्यातली जी काही गढूळता आहे, टर्बिडिटी आहे, ती कमी करतो, त्यात क्लोरीन टाकतो, त्यात आय मीन फिल्ट्रेशन करून क्लोरीन टाकतो आणि स्वच्छ आणि पोर्टेबल पाणी आम्ही तुमच्यापर्यंत पोहोचवतो. आता प्रश्न असा उद्भवतो की लोकांना माहित आहे का की तुम्हाला पाणी किती लागतं? लोकांना माहित असतं की फक्त मला प्रेशरनं पाणी आलं पाहिजे, आणि मला पुरेसं पाणी आलं पाहिजे. आणि इथेच खरी शोकांतिका आहे. जलसाक्षरता, वॉटर लिटरसी हा फार मोठा प्रश्न आमच्या समोर आहे. कारण लोकांना वाटतं मला पाहिजे त्या वेळेला पाहिजे तेवढं पाणी आलं पाहिजे, परंतु आपल्याला प्रत्यक्षात पाणी किती लागतं याची लोकांना जाणीव पाहिजे. बऱ्याच लोकांना माहित नसतं की पाणी कुठून येतंय, पाणी किती लागतंय आणि आपण कसं वापरायला पाहिजे. म्हणून पहिल्यांदा जलसाक्षरता जी आहे ती महत्वाची आहे. आता आमच्या आपू घरच्या जलशुद्धीकरण केंद्रामधून आयदर पंपिंग किंवा ग्रॅव्हिटीने पाणी त्या भागातील पाण्याच्या उंच टाकीमध्ये जातं आणि त्या विहित वेळेनुसार पाण्याचं वितरण होतं. आता पाण्याचं वितरण आम्ही रोज करतो. जर पश्चिम महाराष्ट्राचा विचार केला तर हा पाणी समृद्ध आहे, त्यामुळे कुठलीही पडत नाहीये. परंतु लोकसंख्या ज्या प्रमाणात वाढते त्या प्रमाणात आपल्याला उद्भव नाहीये. आता आपण जे काही आव्हानं आम्ही दररोज फेस करतो वॉटर डिस्ट्रीब्युशन करताना, दैनंदिन पाणी पुरवठा करताना, त्यातलं पहिलं म्हणजे नागरिकांची तक्रार असते की पाणी प्रेशरने येत नाहीये. त्यानंतर पाणी पुरेसं येत नाहीये. पाणी आता कधी कधी पाणी घाण पाणी पण येतं, गढूळ पाणी येतं. आणि मग या अडचणींवर काय करायचं. आता प्रथमतः विचार केला जो आपला डेव्हलपमेंट प्लॅन आहे, ऍक्च्युली should grow as per the development plan. विकास आराखड्याच्या पद्धतीने कायदेशीर मार्गाने बांधली जाणारी सर्व जर घरं असतील, इन्फ्रास्ट्रक्चर डेव्हलप करणं सोपं जातं. परंतु जो सर्व शहरांना शहरीकरण होताना जो भेडसावणारा जो प्रश्न आहे तो अनऑथराइज कन्स्ट्रक्शन्स हा एक आहे. तसंच लँड ऍक्विजिशन करताना, कारण आम्हाला जेव्हा डीपी इम्प्लिमेंटेशन करायचं असतं तेव्हा त्या भागातील आरक्षण आम्हाला डेव्हलप करायचे असतात. मग आरक्षणासाठी रस्त्याचं आरक्षण असेल, कारण रस्त्याचं आरक्षण जर डेव्हलप करायचं तर रस्त्याची म्हणजे आम्हाला पाईपलाईन आहे, त्या तिथे बांधकाम परवानगी देताना आम्हाला तिथं पाण्याची सोय करणं थोडं जड जातं. आता प्रथमतः विचार करूया की सद्यस्थितीत असलेली जी लोकसंख्या आहे त्या लोकसंख्येला पाणी पुरवठा करताना येणाऱ्या अडचणीबाबत आपण विचार करूया. तर सगळ्यात साधारणतः जो नॉन रेव्हेन्यू वॉटर आहे ते साधारणतः 20% ते 60% नॉन रेव्हेन्यू वॉटर आढळतं. म्हणजे जेवढं पाणी आम्ही सोर्स मधून उचलतो त्यापैकी फक्त 40 ते 60% पाणी प्रत्यक्षात आमच्या नागरिकांपर्यंत पोहोचते. मग याचा अर्थ तुम्ही समजायचा की 40% पाणी अशी बात. हा जो नॉन रेव्हेन्यू वॉटर आहे त्या ह्याच्यामध्ये गळतीचं प्रमाण पण आहे एक, त्यानंतर पाण्याची चोरी 2 आणि तिसरं म्हणजे नॉन रेव्हेन्यू वॉटर कमी करणे हे एक सगळ्यात मोठं चॅलेंजेस आमच्या समोर आहे. दुसरं म्हणजे लोकांना जाणीव करून
Tambe sir, you are not audible. Yeah.
हॅलो, तांबे सरांना जरा रेंजचा प्रॉब्लेम येतोय, रेंज मध्ये जात आहेत ते.
Okay, sir. Yeah.
Audio and video is not available.
No, he has facing some network problem. Just wait.
आता येणार आहे ते.
नाही सर, ऑडिओ
अवघड आहे सर. मोबाईलवर कनेक्ट बघू, मी प्रयत्न करतो सर. ओके, ठीक आहे. हॅलो, आता येतोय का आवाज?
हो सर, आता येतोय.
हॅलो,
Yes,
आता
sir.
येतोय ना?
सर, ऑडिबल.
येस. हा हा
ऑडिबल
हा.
सर.
मग मी
प्लीज कंटिन्यू सर.
आता परत पहिल्यापासून सुरुवात करू का? हॅलो,
विल कंटिन्यू.
या
No need to go
Yeah.
back.
Yeah. Now, as per the water distribution challenges are concerned, as I told already that citizens want the water at pressure, abundant water, whatever quantity they require. And
Video is not available, sir.
hello,
Video.
हा एक मिनिट, मी व्हिडिओ बंद केला होता कारण आवाज व्यवस्थित यावा म्हणून.
सर, आय थिंक व्हिडिओ बंदच राहू द्या. बँडविड्थ जास्त लागतं सर व्हिडिओला. आय गेस वी विल कंटिन्यू विथ द ऑडिओ. येस सर.
ओके. मग मी व्हिडिओ बंद ठेवूनच बोलतो. तर या पार्श्वभूमीवर आमची लोकसंख्या वाढते, पाणी आहे तेवढंच आहे, आणि या पार्श्वभूमीवर पाण्याचं नियोजन करताना आम्हाला सगळ्यांना व्यवस्थित पाणी द्यायचंय, पुरेसं पाणी द्यायचंय आणि समन्यायी पाणी पुरवठा करायचा, म्हणजे इक्विटेबल वॉटर डिस्ट्रीब्युशन. या पार्श्वभूमीवर आम्हाला ज्या अडचणी येत होत्या त्या अनुषंगाने राज्य शासन आणि केंद्र शासन यांच्या मदतीने आम्ही सुरुवातीला JNNURM व नंतर अमृत मिशनच्या माध्यमातून सर्व नागरिकांना पुरेशा दाबानं पाणी देणं आणि पेयजल देणं, चांगल्या उच्च प्रतीचं पाणी देणं, हे उद्दिष्ट डोळ्यासमोर ठेवून काही प्रकल्प हाती घेतले. आणि निश्चितपणे त्या प्रकल्पाच्या माध्यमातून काम करताना मी आता पुढे सांगणारच आहे की कोणकोणत्या पद्धतीने आम्ही काम करतोय. ती कामं करताना आम्हाला असं जाणवलं की नागरिकांच्या मध्ये जलसाक्षरता निर्माण करणे फार महत्वाचं आहे. तसंच डीपी इम्प्लिमेंटेशन करताना वी शुड गो हँड इन हँड विथ द डेव्हलपमेंट. म्हणजे जेव्हा बिल्डर्स, विकसक नवीन इमारती उभ्या करतायत, लोक घरं बांधतायत, आणि त्याच वेळेला आमचं इन्फ्रास्ट्रक्चर सुद्धा पॅरलली चाललं पाहिजे. आता जवळजवळ आम्ही JNNURM अंतर्गत 150 कोटीचं काम करतोय आणि अमृत मिशनच्या अंतर्गत 250 कोटीचं काम करतोय. अर्थात ही कामं केली म्हणजे संपलं असं नाही, कारण लोकसंख्या वाढतीये. पुढची जे काही आता आमचा चरोली भाग आहे, रावेत भाग आहे, वाकड भाग आहे, या भागात अजून देर इज अ मच पोटेन्शियल टू ग्रो. म्हणजे त्या तिथे आता फक्त करोना थोडी वाढ थांबलेली आहे, परंतु करोना नंतर पोस्ट करोना निश्चितपणे वाढीला वाव आहे. आणि मग आमच्या समोर चॅलेंज असणार की तिथं जे वाढणार शहर आहे त्या शहराला सुद्धा पाणी व्यवस्थित द्यायचंय. तर सगळ्यात महत्वाचं म्हणजे मी माशी सांगितल्याप्रमाणे नॉन रेव्हेन्यू वॉटर, हिशोब बाह्य पाण्याचं प्रमाण, त्या प्रमाणामध्ये पाण्याच्या गळतीचं प्रमाण हे सगळ्यात जास्त आहे. साधारणतः अराउंड 25 to 30% ऑफ द टोटल वॉटर हे गळतीमध्ये जाते. मग तुम्ही म्हणाल गळती मग तुम्ही का थांबवत नाहीये? तर गळती ही 3 प्रकारची आहे. एक पहिली गळती म्हणजे ट्रान्समिशन लाईन मधली, म्हणजे आपला जो अशुद्ध पाणी पुरवठा जिथून होतो, जिथून पंपिंग होतंय तिथून आपलं जे जलशुद्धीकरण केंद्र आहे तिथपर्यंत जी काही पंपिंग लाईन येते त्यातली गळती. त्यानंतर जलशुद्धीकरण केंद्रामधून प्रत्येक टाकीपर्यंत येणारी जी लाईन आहे मेन ट्रान्समिशन लाईन त्यातली गळती. अर्थात या 2 लाईन मध्ये प्रचंड दाब असल्यामुळे कुठेही लिकेज झालं तर ते तात्काळ समजतं, त्यामुळे तिथल्या लिकेजचा प्रश्न येत नाहीये. त्यानंतर त्याच्यामध्ये परत जलशुद्धीकरण केंद्रामधले जे काही ट्रीटमेंट चालते, प्रक्रिया चालते, म्हणजे एरेशन फाउंटन असेल, त्यानंतर क्लॅरिफ्लॉक्युलेटर असेल, किंवा फिल्टर असेल, रॅपिड सँड ग्रॅव्हिटी फिल्टर, किंवा आपल्या क्लिअर वॉटर संपवेल त्यातली गळती असू शकेल. आणि नंतर टाकीमधून जेव्हा आपण नागरिकांच्या घरात जेव्हा प्रत्येक ठिकाणी आपण सबमेन्स आणि नंतर डिस्ट्रीब्युशन आहेत त्यातले लिकेजेस आहेत. आणि सगळ्यात महत्वाचं लिकेजेस म्हणजे आमच्या महानगरपालिकेच्या किंवा अर्बन लोकल बॉडीच्या पाईपलाईन वरून जे कनेक्शन तुम्ही घेता बिल्डिंगला किंवा घरांना किंवा इमारतींना जे दिलं जातं त्यातली होणारी गळती, लिकेज हे फार महत्वाचं आहे. आणि सगळ्यात महत्वाचं पुढचं लिकेज म्हणजे तुमच्या घरातलं होणारं लिकेज आहे. कारण तुमची पाण्याची जी टाकी असते त्या टाकीतून लिकेज होऊ शकतं. त्यानंतर तुमचं जे काही इंटरनल डिस्ट्रीब्युशन सिस्टीम आहे तुमच्या इमारतीमधील त्यातही लिकेज होऊ शकतं. आता आपण एका गोष्टीकडे जाऊया की साधारणतः पाण्याच्या टाकीपासून तुमच्या कनेक्शन पर्यंत अर्बन लोकल बॉडी इज रिस्पॉन्सिबल टू सर्च फॉर द लिकेजेस अँड स्टॉप फॉर द सेम. आता हे लिकेजेस कशा प्रकारचे असू शकतात? जुन्या काळी आपल्या ज्या पाईपलाईन होत्या त्या सीआयच्या होत्या आणि त्याला जे जॉईंट्स होते ते शिशाचे होते, लीड जॉईंट वेअर देअर. आता लीड जॉईंट जे आहेत, आवाज येत नाहीये का? हॅलो, एम आय ऑडिबल
सर? प्लीज कंटिन्यू.
हॅलो,
यस, ऑडिबल सर. प्लीज कंटिन्यू.
तुम्ही जे काही लीड जॉईंटचे जे सीआय पाईप होते, मग हिवाळ्यात काय व्हायचं की लीडचा थर्मल कोइफिशियंट वेगळा आहे आणि कास्ट आयर्नचा थर्मल कोइफिशियंट वेगळा आहे, त्यामुळे त्याचं आकुंचन आणि प्रसारण हे वेगवेगळं असल्यामुळे प्रचंड प्रमाणात गळती त्या लीड जॉईंट मधून व्हायची. आता या लीड जॉईंट मधून गळती होत असल्यामुळे प्रचंड प्रमाणात पाणी वाया जायचं. अर्थात वेळोवेळी आमची जी काही दुरुस्ती करणारी टीम आहे ती करायचीच. आणि मग तसं करताना त्याच्यावर अर्थात कंट्रोल कमी व्हायचं. परंतु आता डीआय पाईप्स आलेले आहेत, डक्टाईल आयर्न पाईप्स आलेले आहेत विथ रिंग जॉईंट, म्हणजे रबरी रिंग्स आहेत, त्यामुळे हा प्रश्न आम्ही मिटवलेला आहे. आणि दुसरं म्हणजे जवळजवळ आमचं पिंपरी चिंचवड महानगरपालिकेचं जे काही डिस्ट्रीब्युशन नेटवर्क आहे ते आता मी मागाशी सांगितल्याप्रमाणे JNNUM आणि अमृत मिशनच्या माध्यमातून आम्ही जवळजवळ सगळे सीआय लाईन्स विथ लीड जॉईंट आम्ही बदललेले आहेत. 1-2 ठिकाणी राहिलेले आहेत, ते पण काम चालू आहे. दुसरं म्हणजे जे एअर वॉल्स असतात, लोकांना माहित नसतं की जे एअर वॉल्स असतात ते पाईप मधले एअर बाहेर काढायचं काम करतात. आणि जर पाईपमध्ये एअर तशीच राहिली आणि दाब वाढला तर पाईपलाईन पण फुटण्याची शक्यता असते. म्हणून जे काय ॲपर्टनन्स आहेत, एअर बॉल्स आहेत, त्याची वेळोवेळी दुरुस्ती आमच्या मार्फत केली जाते. आता सगळ्यात महत्वाचं मी मगाशी सांगितलं की एकूण 25 ते 30% जी काही गळती आहे, त्या गळतीपैकी जवळजवळ 60% भाग हा नागरिकांच्या नळजोडांमधून होतो. नागरिकांचा नळ जो आहे तो पूर्वी गॅल्वनाइज्ड आयर्न पाईप्स आहे, GI पाईप जे आहेत, म्हणजे अर्धा इंच, पाऊण इंच, 1 इंच, 1.5 इंच, 2 इंच. आता 2 इंचाच्या आपण DI पाईप वापरतो, परंतु जे काही GI पाईप आहेत, GI पाईप जरी गॅल्वनायझिंग करून त्याच्यावर जरी चांगला थर दिला असला तरी 8 ते 10 तो जमिनीत असल्यामुळे 8 ते 10 वर्षानंतर त्याची गंजण्याची प्रक्रिया चालू होते. आणि गंजण्याची प्रक्रिया चालू झाल्यानंतर त्याला भोकं पडतात, होल्स पडतात आणि ते त्यातून मग जेव्हा आपला पाणी पुरवठा चालू असतो, तो प्रेशर नसतो, तेव्हा पाण्याची गळती जमिनीत पाणी जातं आणि जेव्हा आमचा वॉलमन वॉल बंद करतो तेव्हा पाणी बंद झाल्यानंतर आतला प्रेशर कमी झाल्यानंतर ते जमिनीत गेलेलं पाणी घाणीसहित आपल्या नेटवर्क मध्ये येतं आणि घाण पाण्याचे प्रश्न सुरू होतात. आणि मग तुम्हाला माहिती आहे घाण पाण्याचे प्रश्न सुरू झाल्यानंतर ते फक्त त्या एकट्या माणसाच्या त्या कनेक्शन ज्याचं कनेक्शन गंजलेलं आहे त्या माणसापुरतं न राहता त्या कॉलनीमध्ये पूर्णपणे ते घाण पाणी जातं आणि वॉटरबोर्न डिसीजेस म्हणजे जलजन्य आजारांचा धोका निर्माण होऊ शकतो. मग आम्ही याच्यावर या मगाच्या दोन्ही प्रोजेक्टच्या माध्यमातून आम्ही सर्व कनेक्शन्स जवळजवळ आमच्या पिंपरी चिंचवड महानगरपालिकेमध्ये 1.5 लाखाच्या वर कनेक्शन्स आहेत. एकूण 5.5 लाख सदनिका आहेत, मिळती आहेत. अर्थात मिळकती 5.5 लाख असल्या तरी काही बिल्डिंग मध्ये 200 फ्लॅट्स आहेत, काही बिल्डिंग मध्ये 100, 8, 10. सो डिपेंडिंग अपॉन द बिल्डिंग साईज आम्ही कनेक्शन दिलेले आहेत, त्यामुळे कनेक्शन संख्या कमी आहे. आता ह्या सगळ्या जे काही कनेक्शन्स आहेत ते आम्ही MDP पाईप मध्ये बदलतोय. म्हणजे जुने जे काही GI पाईप्स आहेत ते सर्व आम्ही बदलतोय. आणि या जे मॉडरेट डेन्सिटी पॉलिथिलीन पाईप्स याचा एक फायदा आहे की अर्धा इंच, पाऊण इंच, 1 इंचीपर्यंत ते कॉईल मध्ये मिळतं. म्हणजे 50-50 मीटर विदाउट जॉईंट आपल्याला ते पाईप मिळतात. ते पाईप आपण कसेही टाकू शकतो. आणि त्याचे जे काही DI पाईप, समजा DI पाईपला जॉईंट करायचं असेल तर सॅडल पद्धतीने कनेक्शनचं हे आहे. आणि समजा HDPE पाईप म्हणजे काही ठिकाणी आम्ही डिस्ट्रीब्युशन सिस्टीमसाठी हाय डेन्सिटी पॉलिथिलीन पाईप वापरतो, तर ते HDPE पाईपवर आम्ही वेगळ्या पद्धतीनं कनेक्शन्स करतो की तिथं मग गंजण्याचा काही संदर्भ नाहीये. त्या MDPE पाईपला कनेक्ट आय मीन जॉईंट्स नाहीयेत, त्यामुळे आणि ते 50 वर्ष त्याला काही होत नाहीये. फक्त MDPE पाईपचं एक वैशिष्ट्य आहे, जमिनीखाली जर असेल तर त्याला काहीही होत नाही. फक्त जमिनीच्या वर जर तुम्ही जर म्हणजे सूर्यप्रकाशाला ते जर हे झालं तर त्या मात्र फेडअप होऊन ते ब्रिटल होऊ शकतं. म्हणून हे जे काही MDPE पाईपचं कनेक्शन आहे ते जमिनीखालीच राहील याची दक्षता घेणं आवश्यक आहे. आणि मात्र वरच्या बाजूला आल्यानंतर रेग्युलर GI पाईप वापरला तर चालेल. जर तुम्ही पाहिलं असेल तर GI पाईप हा जमिनीवर आणि सूर्यप्रकाशात त्याला काही होत नाही. फक्त जमिनीखाली जर असेल तर प्रॉब्लेम येतो. म्हणून MDPE पाईप जमिनीखाली आणि तेच कनेक्शन वर आलं तर GI पाईप हे असं कॉम्बिनेशन वापरलं आणि सुदैवाने 2009 पासून आमच्या इथे मीटर्स आहेत. आणि हे जे वॉटर मीटर आहेत, 11 वर्ष वॉटर मीटर आहे, आम्ही व्हॉल्युमेट्रिक बेसिसवर पाणी बिल चार्ज करतो. आणि आता आम्हाला समजायला लागलं की कोणत्या भागात किती पाणी जाते. म्हणून आमच्या इथे आता ती सोय पण आलेली आहे की किती पाणी द्यायचं हे आम्ही ठरवू शकतो. मग या पार्श्वभूमीवर लोकांनी पण आता पुढचा असा विचार केला पाहिजे की पाणी टाकीमध्ये आलं, पाणी टाकीमध्ये आल्यानंतर आता मी लोकांच्या भागातला इमारतीमधील जो लिकेजेस आहेत त्याचा मी उहापोह करणार आहे. जेव्हा पाणी अंडरग्राऊंड वॉटर टँक मध्ये येतं आणि तिथून तुम्ही पंप करता. आता जी काय अंडरग्राऊंड वॉटर टँक आहे ती साधारणतः 10 वर्ष त्याचं वॉटर प्रूफिंग टिकतं. परंतु त्याच्या पुढे गेल्यानंतर ते वॉटरप्रूफिंग जर काही अडचण आली तर मग त्या जमिनीतल्या पाण्याची जी टाकी आहे तिथून पाणी जमिनीत मुरू शकतं आणि तिथून लॉस होऊ शकतात. त्यामुळे सर्वांनी ही काळजी घेतली पाहिजे की पाण्याची जी टाकी आहे ती दर 10 वर्षांनी व्यवस्थित वॉटरप्रूफिंग केली पाहिजे. दुसरं म्हणजे जेव्हा तुम्ही पंपिंग करून अंडरग्राउंड वॉटर टँक मधलं पाणी तुम्ही ओव्हरहेड टँक मध्ये टाकता, ओव्हरहेड वॉटर टँक मध्ये पाणी टाकताना जे काही समजा कधी कधी पाणी ओव्हरफ्लो झालं तरी कुणीच पंप बंद करत नाही. सो दॅट केअर शुड बी टेकन की अंडरग्राउंड वॉटर टँक असो किंवा ओव्हरहेड टँक असो, इट शुड नॉट गेट ओव्हरफ्लोड. त्यानंतर दुसरं तुमचे जे काही इंटरनल डिस्ट्रीब्युशन आहे प्रत्येक घराघरामध्ये किंवा हॉटेलमध्ये किंवा कुठल्याही व्यावसायिक किंवा इन्स्टिट्यूशनल यूज असेल त्या ठिकाणी प्रत्यक्ष पाणी गेल्यानंतर तुमचे जे नळ असतात त्या नळातून नळ जर चुकून चालू राहिला तर एका रात्री तुमची 10,000 लिटरची टाकी खाली करू शकतो. म्हणजे तो अर्थात तो जो लॉस आहे तो आमच्या मीटरवर दिसू शकतो किंवा तुम्हाला आम्ही या दिवशी पाणी पुरवलेलं आहे परंतु ते पाणी तुमच्या हातून वाया गेलेलं आहे. परंतु शेवटी पाणी वाया पिंपरी चिंचवड महानगरपालिका किंवा ULBच्या पाईपलाईन मधून गेलं किंवा नागरिकांच्या घरातून गेलं पाणी तर वाया जाणार आहे. म्हणून पाणी वाया जाऊ नये याची काळजी आपण घेतली पाहिजे. दुसरं म्हणजे जेव्हा आपण आता बरेचसे अनऑथराइज्ड कनेक्शन्स आमच्या दृष्टिक्षेपात येतात. बेसिकली कुठलीही वसाहत वाढताना कुठली संस्कृती वाढताना काही गोष्टी ज्या आम्हाला चॅलेंज वाटतात की मी मगाशी म्हटल्याप्रमाणे की सर्व जर काही सुरळीत कायद्यानुसार चाललं तर आम्हाला ही सर्व्हिस देताना निश्चितपणे चांगलं वाटेल. परंतु आता काही शहरामध्ये झोपडपट्ट्यांचा प्रॉब्लेम आहे, अनधिकृत घरांचा प्रॉब्लेम आहे. अर्थात सामाजिक दृष्टिकोनातून त्यांना पाणी देणे आमचं कर्तव्यच आहे. मग परंतु काही काही वेळेला ते एक वेगळ्या भावनेतून ते आम्हाला ऍप्लिकेशन करत नाही आणि अनधिकृत कनेक्शन घेतात. एक अपराधीपणाची भावना असते की मी अनधिकृत घर बांधलेलं आहे मग आता मी कसं काय अप्लाय करायचं म्हणून ते अनधिकृत कनेक्शन घेतात. तर आम्ही अनधिकृत कनेक्शन्स नियमित करण्यासाठी ॲम्नेस्टी स्कीम पण राबवलेली आहे. जवळजवळ आमचे जवळजवळ 10 ते 12,000 अनधिकृत कनेक्शन आम्ही या 2 वर्षामध्ये रेग्युलर केलेले आहेत. सगळ्यात महत्त्वाची गोष्ट म्हणजे की अनधिकृत घरं जेव्हा बांधतात लोक तेव्हा ते कुठलाही साइड मार्जिन किंवा फ्रंट मार्जिन काहीही कुठलाही विधिनिषेध न बाळगता ते करतात आणि बांधकाम करतात आणि वर 4-4 मजली बांधकाम करतात आणि त्याच वेळेला पाण्याची टाकी मात्र बांधण्याचे कष्ट ते घेत नाही आणि मग डायरेक्ट पंप लावतात आणि मग त्यांनी पंप लावून वरची टाकी मात्र मोठ्या क्षमतेची असते आणि मग पंप लावल्यानंतर एका माणसाने पंप लावला तर 10 लोकांचं पाणी जातं. म्हणजे हे सुद्धा चॅलेंज आहे आमच्या इथे. म्हणून आम्ही सगळ्यात महत्वाचं म्हणजे लोकांचं जे काही प्रबोधन करणं हा एक महत्वाचा भाग पिंपरी चिंचवड महानगरपालिकेच्या पाणी पुरवठा विभागाने हाती घेतलेला आहे. दुसरं म्हणजे 24/7 खरं तर जर आमच्या डिस्ट्रीब्युशन सिस्टीम मध्ये पाण्याचा दाब हा चांगल्या पद्धतीने राहिला तर निश्चितपणे लोकांना इक्विटेबल डिस्ट्रीब्युशन मिळेल. आणि असं करताना लोकांनी पण जाणीव ठेवली पाहिजे आपण पाणी किती वापरलं पाहिजे. अर्थात आता सगळ्यांना मी एक पाणी किती वापरलं पाहिजे याविषयी मी सांगतो या लेक्चरच्या माध्यमातून. आपला जो नॉर्म आहे तो नॉर्म 135 LPCDचा आहे. म्हणजे एका कुटुंबामध्ये समजा 5 लोक असतील तर प्रत्येकाला 135 लिटर एका माणसानं वापरलं पाहिजे एका दिवसाला. मग याची जर फोड करायचं म्हणलं तर तुम्ही जर अगदी क्रिटिकली गेलात तर तुम्हाला तुमच्या असं लक्षात येईल की एका माणसाला 100 लिटर पाणी सुद्धा पुरेसं आहे. मग 35 लिटर जो आहे तो जो काही क्लायमॅटिक जे काही व्हेरिएशन आहे उन्हाळा हिवाळा पावसाळा उन्हाळ्यात पाणी जास्त वापरतो मग तेव्हा तो जो 35 लिटर आहे ते उन्हाळ्यातलं जास्त वापरायचं. परंतु काही ठिकाणी 300 LPCD पेक्षाही जास्त पाणी वापरलं जातं. मग आता 300 LPCD पाणी म्हणजे हा हव्यासाचा परिणाम झाला. त्यामुळे जे पाणी वापरायचे ते नागरिकांनी अगदी व्यवस्थित वापरलं पाहिजे, तर आपण सगळ्यांना पाणी व्यवस्थित देऊ शकतो. मग या पार्श्वभूमीवर आम्ही टेलिस्कोपिक दर ठेवलेले आहेत. जे पाणी बिल आहे ते टेलिस्कोपिक पद्धतीने ठेवलेले आहेत, की साधारणतः 135 LPCD पर्यंत जर पाणी वापर असेल तर समजा 4 रुपये रेट, आणि त्याच्या पुढे जर पाण्याचा वापर गेला तर जास्त हेवी रेट असं आमचं नियोजन आहे. आणि जर तसंच झालं तर निश्चितपणे लोकांच्या पाणी वापरावर बंधनं येतील, आणि तेच पाणी जे काही त्यांनी न वापरलेलं पाणी आम्ही दुसऱ्या भागात जिथं पाण्याच्या अडचणी आहेत तिथं आम्ही टाकू शकतो. आता दुसरा जो काही प्रॉब्लेम आम्ही फेस करतो तो म्हणजे जेव्हा म्हणजे आमचे इतर विभाग पण आहेत, स्थापत्य विभाग आहे, रस्ते करताना म्हणजे पूर्वी रस्ता जो असेल तो कमी रुंदीचा असेल, नंतर ऍज पर डीपी डेव्हलपमेंट प्लॅन रस्त्याची रुंदी वाढवताना आमच्या पाईपलाईन आत जातात. मग त्यासाठी सुद्धा आम्हाला रस्ते खोदावे लागतात, आणि मग त्या वेळेला नागरिक म्हणतात की आम्हाला रस्त्यातून अडचण होते, अपघात होते. नागरिकांनी सुद्धा समजून घेतलं पाहिजे की काही चांगल्या सुविधा देताना थोडाफार त्रास हा होणारच. आता जे काही मेट्रोचं काम चालू आहे त्यामुळे तुम्हाला थोडा त्रास होतोय, परंतु तुम्ही सहन करून घेताय. मग तुम्हाला जी काही सगळ्यात जीवनावश्यक बाब आहे की पाणी, ते पाणी जर तुम्हाला मिळण्यासाठी थोडा त्रास आम्ही सहन केलाच पाहिजे. अपघात होऊ नये, तुमची असुविधा अगदी थोडी कमीत कमी व्हावी म्हणून बॅटरी म्हणून आम्ही प्रयत्नशील असतोच. आणि सगळ्यात महत्वाचं म्हणजे जे काही सिटीजन रिड्रेसल, जे कंप्लेंट रिड्रेसल जे आहे ते आम्ही सारथीच्या माध्यमातून आम्ही प्रत्येक नागरिकापर्यंत पोहोचू शकतो, आणि प्रत्येक नागरिक सारथीच्या माध्यमातून त्यांची तक्रार, म्हणजे ती तक्रार पाण्याची असो, रस्त्याची असो, लाईटची असो, किंवा कुठलीही सुविधा असेल त्या सुविधाची तक्रार तो सारथीच्या माध्यमातून आमच्यापर्यंत पोहोचू शकतो. आणि आम्ही वी आर डायरेक्टली कनेक्टेड टू एव्हरी सिटीजन थ्रू सारथी. आणि हे जे सारथीच्या माध्यमातून कुठली तक्रार आली तर आम्ही ज्युनियर इंजिनियरच्या माध्यमातून आम्ही त्यांच्यापर्यंत पोहोचतो, त्याच्या अडचणी दूर करतो. दुसरं म्हणजे आमचं जे काही पाणी पुरवठा आहे, पाणी पुरवठा पूर्णपणे आम्ही जे मॉनिटरिंग करतो, जवळजवळ गेले 10 वर्षापासून आमची स्काडा आहे, सुपरवायझरी कंट्रोल अँड डाटा ऍक्विजिशन जे आहे. तर स्काडाच्या माध्यमातून माझ्या या मोबाईलवर सुद्धा सगळ्या कोणत्या टाकीमध्ये किती लेवल आहे, किती पाणी पडतंय आणि कोणत्या टाकीमधून किती पाणी जातंय हा पण आमच्या समोर आरसा दिसतो तो. आणि त्या माध्यमातून आम्ही हे वॉटर डिस्ट्रीब्युशन जे आहे ते मॉनिटर करत असतो. शिवाय आम्ही जेव्हा JNNURM आणि अमृत मिशनच्या माध्यमातून काम करत असताना जे डिस्ट्रिक्ट वॉटर मीटर्स म्हणजे DMAs हे जे केलेले आहेत, डिस्ट्रिक्ट वॉटर मीटर एरियाज, तर त्या माध्यमातून त्या डिस्ट्रिक्ट DMA ला किती पाणी लागते, त्या तिथे किती लोकसंख्या आहे, किती पाणी लागते याचा फोरकास्टिंग करून मग आम्ही तिथे डिझाईन करतो. सगळं जे काय आमचं वॉटर नेटवर्क आहे, डिस्ट्रीब्युशन नेटवर्क, ते पूर्णपणे आम्ही डिझाईन करतोय. आवश्यकतेनुसार जुन्या पाईपलाईन बदलतोय, नवीन डायमीटरच्या पाईपलाईन टाकतोय. आता आम्ही सरवली, रावेत, त्यानंतर वाकड या भागामध्ये आम्ही नव्याने जवळजवळ 225 कोटीचे प्रोजेक्ट्स आम्ही आता त्याचं टेंडर काढलेलं आहे की ठिकठिकाणी जवळजवळ 27 टाक्यांचं बांधकाम आम्ही करतोय. आणि त्या टाक्यांना पाणी पुरवण्यासाठी 55 किलोमीटरचं मेन ट्रान्समिशन लाईन्स पण टाकतोय आम्ही. आणि सगळ्यात महत्वाचं म्हणजे पवनेचा जो सोर्स आहे, जवळजवळ 6.5 TMC पाणी आम्ही तिथून उचलतो, म्हणजे त्यातून आम्हाला मिळतं. परंतु आमची लोकसंख्या वाढते आणि ती वाढत्या लोकसंख्येसाठी जास्तीचे जे पाणी लागणार आहे त्यासाठी आम्ही भामा आस्केड मधून जवळजवळ आम्ही 167 MLD पाणी उचलणार आहोत. त्याचं आरक्षण आम्हाला मंजूर आहे इरिगेशनच्या माध्यमातून. आणि आंध्रा प्रकल्प आहे तिथून 100 MLD. चिखली येथे आम्ही आमचं जे काही जलशुद्धीकरण केंद्र जे आहे 100 MLDचं बांधकामाचं सुरुवात केलेली आहे. भामा आस्केड मधून पाणी आणण्यासाठी पाईपलाईन टाकण्यासाठी आम्ही आता वर्क ऑर्डर देतोय आणि इंद्रायणी नदीमधून पाणी उचलण्यासाठी आम्ही आमचं कामही सुरू करतोय. निविदा प्रसिद्ध झालेल्या आहेत. तर अशा पद्धतीने पिंपरी चिंचवड महानगरपालिका वाढत्या लोकसंख्येसाठी पाण्याची तजवीज निश्चितपणे आम्ही चांगल्या प्रकारे करतोय. आता मी मगाशी सांगितल्याप्रमाणे ऍज सब्जेक्ट गिवन इज challenges and improvement in वॉटर डिस्ट्रीब्युशन सिस्टम. तर यात सगळ्यात महत्वाचा भाग हा नागरिकांचा आहे. नागरिक, त्यानंतर लोकप्रतिनिधी आणि प्रशासन म्हणजे आम्ही या एकत्रित टीमवर्कने संघभावनेनं जर काम केलं तर निश्चितपणे आम्ही या शहराला आणि प्रत्येक नागरिकाला इक्विटेबल वॉटर डिस्ट्रीब्युशन समन्यायी आणि सगळ्यांना पुरेल असं पाणी आणि सगळ्यांच्या गरजा भागतील एवढं पाणी आम्ही देऊ शकतो. अर्थात त्यासाठी नागरिकांचा सक्रिय सहभाग, पब्लिक पार्टिसिपेशन हे महत्वाचं आहे आणि नागरिकांची जलसाक्षरता ही पण महत्वाची आहे. आता हे करताना प्लंबर हा एक फार मोठा, प्लंबर म्हणजे खाजगी प्लंबर म्हणतो. आता खाजगी प्लंबर ला तुम्ही विश्वासात घेतलं पाहिजे. तुमचं अॅन्युअल मेंटेनन्स कॉन्ट्रॅक्ट शुड बी देअर की बाबा त्या प्लंबरला महिन्यातून एकदा ये आणि आमचे जे काही नळ कनेक्शन असतील, पाईप असतील त्याच्यातून कुठं लिकेज तर नाहीये ना, हे पण पाहिलं पाहिजे. आता पुढची, आता तुम्ही नांदेड सिटी सारखे जे प्रकल्प आहेत त्यांनी तर प्रत्येक फ्लॅटला मीटर दिलेला आहे. जर तुम्ही मायक्रो लेवलला जर वॉटर मॉनिटरिंग केलं तर निश्चितपणे तुम्ही चांगल्या पद्धतीने हे वॉटर ऑडिटिंग करू शकता आणि त्यामुळे पाण्याचं चांगल्या पद्धतीनं नियोजन होऊ शकतं. आम्ही सुद्धा या स्काडाच्या माध्यमातून दैनंदिन वॉटर बजेटिंग, वॉटर ऑडिटिंग करत असतो. तसंच डेव्हलपमेंट प्लॅन जो आहे, आता आमचा डेव्हलपमेंट प्लॅन रिव्हिजन चालू आहे. तर त्या तिथे भविष्यात लोकसंख्या 2041 ची लोकसंख्या किती आहे आणि 2041 ची जी लोकसंख्या आहे त्या लोकसंख्येला पाणी पुरवठा करताना सोर्स कुठले कुठले असणार आहे आणि कशा पद्धतीनं आम्ही कुठं टाक्याचं आरक्षण करायचं, पाईपलाईन कसे न्यायचे याचं नियोजन आम्ही आत्ताच करतोय. वी आर डुईंग अवर प्लॅनिंग इन ऍडव्हान्स, की नंतर असं व्हायला नको की अरे इथे लोकसंख्या वाढली आणि तिथं पाईपलाईन नाहीये. म्हणून आम्ही आता नेहमीच्या म्हणजे 3 वर्ष आम्ही पुढे आहोत. जे काम आम्ही 2022 ला करणार आहे ते आम्ही आता सुरू केलेलं आहे. त्यामुळे निश्चितपणे पिंपरी चिंचवड महानगरपालिकेच्या परिसरातल्या नागरिकाला चांगल्या पद्धतीनं पाणी हे मिळणार आहे. फक्त मी मागाशी सांगितल्याप्रमाणे जलसाक्षरता ही महत्वाची आहे. मला वाटतं सांगण्यासारखं भरपूर आहे, परंतु कुणाच्या काही शंका असतील तर इट्स ओपन नाउ, प्लीज.
Sir,
Hello.
Rishikesh. Yeah.
Hello.
Hello. Yes, sir. Am I audible?
Ha, please.
So Rishikesh Gurpade asked question: in pipeline distribution network, designing of thrust block is considered as challenging thing. So is there any advanced technique for this concept of thrust block?
As far pumping line is concerned, pumping line and gravity lines, wherever necessary, thrust block is there. But as far as distribution system is concerned, I don't think any thrust block is required.
Okay, sir.
Yes, please. Next.
Next question is from Sanket Bhame. He asked, so what about the water-based industries present in PCMC area? How are they audited?
Okay. Now, as far water-based industries are there, basically, as far industrial area is concerned, MIDC is separate entity, and MIDC is providing water with their separate network to the all to all the industries. So as far industrial area is concerned, MIDC is the authority, and within our network there are hospitals, schools, colleges, and then restaurants and sweet marts. So we are giving commercial connections to them, and all the commercial connections or even institutional connections and even domestic connections are metered connections. So there is we can monitor with the help of meters and the monthly bills. Please next. Hello.
Yes, sir.
Hello.
Yes, sir. We are done with the question answers from
Please
the
next
chat
question.
box. Yeah. Modak sir. Yeah. Please, can you take over? Yeah.
Thank
Now,
you, sir.
any other question?
No, sir, we are done with the questions.
Hello.
So we are done with the questions.
ओके, कोणालाही काही शंका असतील, एक मिनिट फक्त मी घेतो. कोणालाही काही शंका असतील तर तुम्ही माझ्याशी केव्हाही संपर्क साधू शकता.
Thank you, sir. Thank you, Tambe sir, for giving your valuable insights. And I'm sure all the participants must have gained a good experience and what all things you explained to them. Thank you, sir, once again, and would like to have the same association with you in the future also. Thank you, sir.
Thank you.
So we are done with the session 2 and we'll have a break and we'll again meet at 2 o'clock for the third session. Thank you very much.
Thank you, Tambe sir.
Sir, can we turn on the videos for photographs, please? Yeah, please, can we turn?
Yes.
Yeah. Tambe sir, please, can you just switch on your video? Yeah, I think that will be. Tambe sir, am I audible?
Yeah.
Yeah. So please,
yes,
can
yeah.
you switch on? Yes, sir.
Yes.
So please, can you turn on your video? We'll just click a photograph.
या येस, व्हिडिओ चालू केलेला आहे. मी दिसतोय का?
येस सर दिसतोय सर व्हिडिओ.
येस 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 बोला. येस.
थोडं नेटवर्कचाच प्रॉब्लेम दिसतोय. दिसतोय आता सर.
शंतनू.
ओके.
Yes, 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 yes. Yes.
Also from the department side, I welcome Dr. R. Manivanan from CWPRS Pune. Also from department side, I welcome Dr. Jagdish Lambe sir. Also I welcome Dr. Bokil madam from MIT Pune.
Okay, sir. We are done with the photographs. Yeah. Thank you, sir.
Yeah. Thank you.
Thank you, Tambe sir.
Yes, sir. Thank you.
अबे सर व्हिडिओ चालूच ठेवा ना फोटोग्राफीला.
झालं, फोटोज घेतले सर. या
घेतले का? ओके ओके.
थँक्यू
तांबे सर. थँक्यू तांबे सर.
ठीक आहे. Thank you.
Thank you sir. Have a good day.
We have the same link for session 3 also, so everyone can disconnect and join again through the same link again for session 3 at 2 o'clock.
So right now we'll take the lunch break. So the further session will be started with the same link at 2 o'clock.
आपण पण डिस्कनेक्ट झालं तर चालेल का सर नांगरे सर?
हा चालेल ना, आता आपण याच लिंकला परत जॉईन होऊ.
ओके
2 वाजता. चॅट बॉक्स मध्ये बी टाका सेशनचा पुढचा. शंतनू,
हो सर.
प्लीज पुट अप इन चॅट बॉक्स वेदांत
हो सर.
येस सर.
regarding schedule. So on the behalf of departments, those who have attended the first 2 sessions, always thankful to you and will continue your the cooperation in next session. आता वेदांत 2 वाजता आपण भेटायचं ना?
हो सर, 2 वाजता.
चालेल. मग
वेदांत
आता लिव्ह केलं तर चालेल?
चालेल सर.
हॅलो वेदांत,
हा सर.
माळी सर ना एक 15 मिनिट आधी जॉईन होतील. ते व्हिडिओ प्ले होतात ते चेक केलं पाहिजे. यू टू चेक वेदर व्हिडिओज आर गोइंग टू प्ले ऑर नॉट.
चालेल
सर
सर.
We'll start at 1:45. From our side, we'll start at 1:45.
All core committee
चालेल
members
सर.
should have meet 1:45.
Yes, absolutely right. Okay.
चला, गुड डे.
Good day. Thank you.
वेदांत मग वेंड करतो मीटिंग.
नाही सर, मीटिंग ही मी चालूच ठेवेन माझ्या एंडला. डिस्कनेक्ट झालं तरी चालेल.
असणार काही.
Okay.